In this video, we're going to solve inequalities and then we're going to graph it on a number line. Before we start, let's review our inequality signs. So the first one we have is less than, and you draw the less than symbol like this. Then we have greater than. Here's our greater than symbol. The next one we have is less than or equal to. And it's a less than sign with a line underneath it. And then finally, greater than or equal to. That one looks like this. You dealt with inequality signs a lot in middle school, and you also dealt with them in Unit 1. So you have seen them before in my class, but now we're going to go into greater detail with the inequality signs. So starting with our first two examples, we're just going to cover graphing these on a number line. We did practice this a little bit the first week of school, but to go back over it, if you're graphing x is greater than 5, then at 5, you're going to have an open circle because your inequality sign is not underlined. If I'm wanting to shade everything greater than 5, then I want to shade to the right because 6 is greater than 5, 7 is greater than 5, and so on. For my next example, x is less than or equal to -3. Remember, negatives go in the opposite direction. First, I'm going to put a closed circle at -3 because my inequality sign is underlined. Then I want to shade everything less than -3. So I would shade to the left. -4 is less than -3, -5 is less than -3, and so on. This part should be a review. What we're going to add today is that we are going to solve our inequality and then graph it. So looking at number 1, your goal here is to get x by itself. So if I'm trying to move over the 3, the opposite of multiplying by 3 is to divide both sides by 3. You can still draw in your algebra wall if that makes you feel comfortable. Once you divide by 3, they cancel on the left and you're left with x, and 9 divided by 3 is 3. When we graph this on a number line, I have a closed circle at 3, and I'm shading everything to the right. I can plug in any number greater than 3 to my solution and it would work. 4 would work, 5 would work, and so on. On number 2, put a big star next to number 2. Number 2 has a special rule that you may or may not have seen before. On number 2, when you solve this, to get rid of the -4, you have to divide both sides by -4. When you do this, you have to be really careful with your sign. -6 divided by -4 gives me +4. Here's where a new rule comes into play. Anytime you multiply or divide by a negative, you have to flip your inequality sign. So go ahead and make a note of that here. When you multiply or divide by a negative, flip the inequality sign. Now, key word here is the word by. It does not matter that the 16 was negative. That does not affect anything. It's only what you're dividing by. Since I divided by -4, that's what causes me to flip my inequality sign. Now we're ready to graph this. At 4, I have an open circle. I want to shade everything greater than 4, so I shade to the right. Now we have a two-step inequality, so we're going to solve this just like we did our two-step equations, and then we're going to graph it. So if I'm trying to get x by itself, the first thing I need to move is the +7. The opposite of adding 7 is to subtract 7 on both sides. When I do that, the 7's cancel on the left, and I'm left with 3x. On the right, 16 minus 7 is 9. Now I'm ready to divide by 3, and since 3 is not negative, I don't have to flip my inequality sign. So my answer is x is less than 3. 9 divided by 3 gives me 3. On my number line, since my inequality sign is not underlined, it cannot equal 3, so I use an open circle. From here, I want to shade everything smaller than 3, everything less than 3, so I shade to the left. I could plug in any of these numbers for x, and it would give me a true statement. For example, if I plug in 1, 1 is less than 3. This is true. 2 is less than 3. This is true. Negative 10 is less than 3. Anything to the left of 3 can be plugged in for x. Our next example is negative 2x plus 8 is greater than or equal to 18. So you can draw on your algebra wall, and again, your goal is to get x by itself. So to move over the plus 8, the opposite is to subtract 8. And this becomes negative 2x, and on the right, 18 minus 8 is 10. Our next step is to get rid of the negative 2, and to do this, you're going to divide both sides by negative 2. Since I am dividing by a negative, you have to remember your special rule, and that is that we need to flip the inequality sign. From here, 10 divided by negative 2 is negative 5. When I graph this on my number line, I have a closed circle at negative 5. X is less than negative 5, so I shade everything to the left. One way that you can check these is to plug in your solution into your original inequality. So for example, if I choose anything to the left of negative 5 or less than negative 5, I can plug it into my original inequality to see if I get a true or false statement. So I'm going to check using negative 7 since I shaded over negative 7. So if I plug that in, I have negative 2 times negative 7 plus 8 is greater than or equal to 18. Well, negative 2 times negative 7 is 14. And 14 plus 8 is 22. This right here is a true statement. 22 is greater than or equal to 18. So I know I did it right. Just remember that on your number line, you want to choose anything being shaded. Negative 4 and negative 3 would not work for this one. All right, now we're getting into our multi-step inequalities. This is the exact same as multi-step equations, so if you're a little rusty on this, go back and watch the multi-step equations video. Your first step is to get rid of your parentheses, and to do that, you're going to distribute. So on the left, 3 times x is 3x. 3 times 6 is 18. Then I'm going to distribute the negative 2. So negative 2 times x is negative 2x. Be careful with your signs. Negative 2 times negative 3 becomes positive 6. A negative times a negative makes that a positive. On the right side, I don't have anything to simplify, so I'm going to keep it as 4x plus 18. From here, you want to combine like terms. The only term I can combine with 3x is the negative 2x, and 3x minus 2x is just 1x, or x. Now I can combine 18 and 6, and 18 plus 6 is 24. From here, I have variables on both sides. I have an x on the left, I have a 4x on the right. Your goal is to get them onto one side. So like I said in the solving equations video, my recommendation is to always move the smaller one. So I would start by subtracting x on both sides. When you do this, you bring down the 24. 4x minus x is 3x. And then you bring down the plus 18. Now you're back to your two-step equation. And even though your variable is on the right, you can still solve this like all your others. We're trying to get x by itself. So your first step is to subtract 18, and we get 6. You can bring down your algebra wall if that helps you. Then you're going to divide by 3. So we get 2. Here's where you have to be careful. When we solve this, we actually end up with x on the right side, and that's totally fine, but you have to be careful when you're shading on your number line. You are not going to shade everything to the left of x. If you look very carefully at this, what I recommend doing is reading this to yourself starting with x. X is actually bigger than 2. 2 is smaller than x. So if you want to rewrite it with x on the left before you graph, that might help make your graphing make a little bit more sense. Always start reading it to yourself starting with your variable. So at 2, since my inequality sign is not underlined, I have an open circle, and then I want to shade everything to the right. You can plug in any number to the right of 2 for x, and it will give you a true statement. Go ahead and pause the video, try these two, and then we'll check together. On number 1, your first step is to get rid of the parentheses. So I would start by distributing the 5. 5 times x is 5x, and 5 times 2 is 10. The right side is completely simplified, so we can just leave it like that. Now we have variables on the same side, so the smaller one is going to be your negative x. To move over negative x, we're going to add it to both sides. The x's cancel on the right, and 5x plus x is 6x. Then you're going to bring down the 22 on the right. From here, we're trying to get x by itself, so we're going to subtract 10 on both sides. And then finally, you're going to divide by 6. Since I'm not dividing by a negative, I don't need to flip my sign. On my number line, I'm going to have an open circle. And x is everything greater than 2, so I shade to the right. On number 2, we need to start by combining like terms. Negative 4x plus 2x combines to give us negative 2x. 9 minus 10, be careful with your signs, always take the sign in front, becomes negative 1. From here, I have negative 2x on the left and negative x on the right. I would move the negative 2x. To do this, you're going to add it to both sides. So negative 1 is on the left, and 1 plus 1x, or 1 plus x, goes on the right, because negative x plus 2x would give you 1x. From here, the only thing left to do is to move the 1 over, because you want x by itself. So since that's a positive 1, you're going to subtract 1 over to get negative 2. Since I didn't divide by a negative, I don't need to flip my sign. But here's where you need to be careful. When you read this to yourself for graphing, remember to always start with your variable. So if I'm reading this to myself, x is less than or equal to negative 2. So when I graph this, I have a closed circle at negative 2, and I am shading to the left.